Now consider one more example of priority scheduling algorithm with preemption. We have 5 processes. These are the arrival times, burst times and priorities. In this example also I am assuming the smallest value has the highest priority. The smallest value has the highest priority. Then it is a preemption. If you have any doubts, you have to clarify in this section. First, what is the starting arrival time? Arrival time 0. So at time 0, we have only one process in the system. If you have only one process, no need to check the priority. Simply allocate the CPU to that particular process. So process P1 at time 0. So what is the maximum required? It maximum required 4 units of time. Suppose execute for 1 millisecond. At 1 millisecond, check any another process entered into the system or not. Yes. At arrival time 1, process P2 is entered into the system. Now you have to check what is the priority of running process 2. The priority of newly coming process is 3. So the running process has the highest priority. So ignore process P2. Now what to do? Execute for 1 more millisecond, that is 2. Now check at arrival time 2 is any another process comes? Yes. At arrival time 2 process P3 is entered. What is the priority? 4. The running process has 2. So the running process has the highest priority. So ignore P3 also. Now run for 1 more second. At arrival time 3, process P4 is entered. See, at arrival time 3, process P4 is entered. Priority is 5. The running priority is 1. Sorry, running priority is 2. That means the running has the highest priority. So, simply ignore P4. Now execute 1 more milliseconds. Here, remember, at the time of execution, you have to consider the burst time also. The P1 burst time is 4. So we have to execute maximum of 4 milliseconds only. At arrival time 4, process P5 is entered, but the burst time is, the priority is 5, the running is 2. Here no need to compare actually. Why? Because all 4 units are completed. All 4 units are completed. That means after completion of 4 units, all the processes are in the system. Why? At 1 process P2, at time 2 process P3, at time 3 process P4, at time 4 process P5 entered into the system. Once you reach the maximum arrival time, then the remaining procedure is very simple. What is the remaining procedure? Simply from this onwards, simply follow the non-preemption approach. That means P1 is completed. Now all the processes are available. Once all the processes are available, suppose observe carefully. If you have all the processes are not available, step by step check the priority of the running process and the newly coming process. Suppose if there is no new process is entered into the system. If there is no new process entered into the system means all the processes are already entered. Then execute according to their priority. So what is the next one? Next one we have to execute process P2. How much time? 3. Now execute process P3. 1. So in this, okay, both have the same priority. If both have the same priority in those cases, we have to consider FCFS. So first P4 is executed. 8 plus 5, 13. Next to P5 is executed. 15. Remember, if both have the same priority, in those cases, follow FCFS. So P4 and P5. First which comes? P3. Sorry. First P4 entered into the system. Okay. Now calculate the wait. First to calculate the completion time. P1 is completed at time 4. P2 7. P3 8. P4 13, P5 15. This is the completion time. Turnaround time is equal to completion time minus arrival time. waiting time is equal to turnaround time minus burst time. Turnaround time minus burst time. Okay. Simply 19 plus 3, 22. 22 by 5. This is the average waiting time. This is the average waiting time. Okay. In the next session, we will discuss a round robin scheduling algorithm.